My name is Jrej, and today I want to show you how to launch your own smart contract on Solana using a Linux setup and Rust. So what we're trying to do is launch this repo from Solana Labs, that is the example HelloWorld, that includes the Rust smart contract that is in source here, and that has also the front end script, so that's in client HelloWorld.ts, so a TypeScript file. So that's what we're trying to set up on our computer. There's a little bit of setup with Linux, since you can't run a validator on Windows, and so that's what we're gonna go through. So what we need to do is install Ubuntu for Windows. So in the store, we find Ubuntu, and we would install that. I have it already installed, so I'll open it. From here, you want to install the latest upgrades and updates. So you would do sudo apt update and upgrade, like this. So it would take a couple of minutes to install everything. Here I want to say continue, Y. All right, that's all complete. So now that it's done, we'll install a node on the Linux. So if I go to the node GitHub source, let me show you here. That is the node source GitHub. You go to the long time support of Node. You can copy this since you're using Ubuntu. And then there's a second part that is optional underneath that we should use as well. That is here, the build essential. Yes, we want to do that as well. That was the 2 lines from the long time support. That was this line, and then we did this line. And now we'll do the build essential here. Okay, this. All right, now that is done, we're finished with Node. We can just add another command for the web stack, that is yarn. So we'll do sudo apt install and yarn. We want to continue. All right, that will install yarn and other dependencies that will be helpful for our front-end development later. This is all a one-off, so if you're doing several projects with the smart contracts, you won't have to do that all again. That's just a one time. So now we install Node, we installed yarn, we can install Rust. So you can go to the Rust website here, rustup.rs, and you'll find this command here. So we'll copy it and then we paste it here. All right, installing. And here we select what type of installation we want. We want default. We select 1 and enter. And we let it go through the installation. The next one would be Solana. So you might have installed it on Windows if you did an NFT collection before. But since we're doing on a different environment here on Linux, we need to install it again. If you go to the Solana documentation, install the Solana suite. In macOS Linux, you can use this command and copy it here. Solana, yes. And then once that's done, we have a setup for the validator. Since we'll be running a validator locally, we do have in start a validator this command here that is system tuning here. that we should use before we run it. All right, so we paste it here. All right, sounds good. So we did Solana, we did the Solana validator setup. All right, so let's have a look at our Solana account. So we do Solana account. So not found. So for that, we need to close it and open it again. And then we tap Solana -- version, and it gives us a version, so that's active now. If we do Solana address, so it would tell us that there's no address found, so it hasn't created a key pair already, so we can do that right away. So we can run this command. So we create a new key pair in this path in the .config folder Solana id.json. So we'll run it. Choose a password. All right, all good. So our address is now this one. Solana address. All right, we're good. And do we have any money? We can have a look at the balance, and we have 0. We need to set up the environment. So here we want to set it up on local. So we do Solana config set --url localhost. All right, so we can see that we're on the RPC localhost with this port 8899, and then the config file, we don't care. The key pair is the correct one. And now if we have a look at the Solana balance, it's not liking it because we don't have the validator running. We'll do that check a little later. All right, so now we want to look into this repo, the example repo from Solana Labs. So we do take it and then do git bash, and we do git clone, and we copy this. All right, so we now have the folder in our C drive in our user desktop. So you open Visual Studio Code. What you want to do is install this extension, that is WSL remote WSL. So this one. So it is installed here. You just need to install this extension, and then you'd see this little window popping up. Otherwise, you can right click and you can access it here. You can take Remote Explorer. You'll see Ubuntu. You can right click and do connect to WSL. It would open a new VS Code. So you can close the other one and keep this one that is open with Linux. And here we want to do File, Open Folder, and we want to look for our example folder. So since it is in the C drive, we want to go through the MNT, the mounted drive, and it is C. And then we're going for the users, my username, and then mine is in the desktop. That is OneDrive Bureau, but probably yours could be in desktop. And then example HelloWorld, and then click OK. This is if you git cloned in the Windows environment. You could also do a git clone in the Linux environment if you wanted. If you, for example, do a cd home and do a git clone here, you could have access git clone here. You could have access to this repo through home, obviously. All right. So first thing we do, it would run the validator, so we can use the local environment for the project. So we do Solana test validator, and it would probably ask you to go through the firewall. So just click accept for any firewall module popping up. So this is running. We'll need to leave it running so we can run our smart contract. We click on this plus sign to open a new terminal. And with this, we need to set up our project. So we do npm install So we would go through the package.json and install the dependencies. And then if we look at the package.json again, you can see some of the commands we're going to type. We have the build program Rust to use the cargo command and build the project. And then we'll use the npm's run start to run the front end, so the main.ts. And basically what this smart contract does, it just increments a number. So it's a very basic implementation, but just so you can see the setup and how it works basically. Basically this is a greet account. So this is the accounts info. So it's just a counter with the type of integer, unsigned integer. If we go into U32 max, it is this amount, 42 million. So yeah, we get space. So an unsigned integer of 32. So that means it is positive only. There can't be any negative sign, and then we can go up to 42 million. But we'll go through the code afterwards. But basically, just so you know, it would increment. So that's not this part, that's this part. It just increments the counter every time you connect to this smart contract. And then it would give you a message with the current counter number. All right, so we installed the dependencies, and so we need to install now we'll build the program, the Rust program with npm run build and program Rust. So that's once again that's this command here, build program Rust, and then it's npm run to run one of these scripts. So it's taking all the Rust files and then compiling them into a SO file. So that is gonna be in dist, I believe. Dist, not there yet. Oh yes, it does mention it right here. So the output directory would be dist program. So we'll wait for that to generate. Okay, now that the dist folder is created, we can deploy this to the network, to the blockchain. So let's just verify we are in the local setup, that we don't push anything to the main net. We have the RPC URL on the local host, and we do have the key pair that is the local key pair. Okay, we're good. So we can now do Solana program deploy, and then the path to the .so file. So we'll do dist program and then HelloWorld.so. All right, let's run that. So the smart contract is deployed. We do have the program ID here for the smart contract. And so we're ready to run the front end. So what it would do, it would send a transaction with an empty instruction. And then the smart contract, as soon as he has a connection, it would create an account for the public key. And it would increment a number for this account. So it would display that on screen. So we'll do npm run start. All right, so it's launching the main.ts file, and then it's establishing a connection. It's using this account that contains my 50 million SOL, and then it's using the program that I created here, that we deployed on the local network. It created an account, and then it counted the number 1. And it's all a success. If we run it a second time, it would do that again and then count 2. It probably wouldn't have to create an account this time. It'd just be using the same. All right, saying hello using this program. and then it didn't create anything, and he greeted 2 times. All right, so that's working. We have our first smart contract on the local network. And this we could deploy on DevNet, we could deploy on mainnet. It is very basic, but it is our first attempt. Let's go through the code a little bit. First, the on-chain code in the program Rust source and the lib.rs, that is the smart contract file. So there's a few dependencies we're setting up for the encoding and then for the Solana program. And then we're setting up the struct here, the creating account with the only information that is a public variable counter, and that is an integer, an unsigned integer of 32 bits. That means it could be up to 42 million something number. It could be U8, U16, U32. It depends on the scope, the size of the number. Okay, this would go to up to 42 million. And then the entry point here, it's where it all starts. So the exclamation mark is for shortcuts. So this we actually imported it from Solana here. And then we're launching this function process instruction. And so this is the parameters. There's a program ID. So that is the program ID of the program. And then there's the accounts. And then the instruction data that in this case would be empty. So nothing here. All right, the message. So, well, this is just a display. And then what it does. So it iterates through the accounts and it gets the proper one. So this is an iterator, and then it takes this method, the next account info, to get the next one. All right, and then it looks for this is a verification part. So it checks that the account owner is the same as the program ID. So because it would only use an account that has been made by this program, so it just verifies that the owner is this program. That's because when it refers to this spot here where they created the account, so the account, the owner has been set as this program. All right, so verifying it's a correct account. On this spot here, the mut makes it mutable. So if you don't put mut with your variable, you can't change it. So it would create an error that we can't add anything. So you should add that for a counter, and then the greeting account.counter. So we're getting the counter, and we added 1. So this plus and equals is the same as doing equals. Greeting accounts counter +1. You could also repeat that and do +1. That'll be the same. But let's stick to that. It's much smaller. For the messages, this part, the curly brackets will be replaced by the variables here, and you could add them twice. If you do another set of curly brackets, you can add another variable here, so that could work. All right, and in the end, it would send the OK. So it's either OK or it could send an error like this. So this is the two possible outcomes of this function. All right. So this is the smart contract. The part where the instructions go through, it's this part. So all the rest, that's basic verification, and this part is where you actually go through the instructions and do stuff. If we go on the client side, in the main.ts, so TypeScript file, it's actually quite a bit of setup as well on the client side. So it does a connection, then it establishes the payer, so just taking the public key of the user, and then checking the program is deployed, just a verification step, and then say hello. This is the start. It's this part here. Let's say hello, and then at the end we are getting this information here of how many greeted times, and then success. All right, and it added a wait at every function because we need to wait for this part to complete before going to the next. So await makes these asynchronous calls into synchronous. So we're waiting every time. And if we go to the HelloWorld.ts, this is the part where all these functions are declared. So we are importing quite a few things here from Solana SDK for JavaScript. So the connection, the public key, the number of LAN ports, and etc. You've probably seen that before if you did a little bit of work on the TypeScript repos of Metaplex. They are using similar things that are the Solana SDK. All right, we're passing all this as just set up. And so here the greeting accounts, we're creating a class with a character. So it is mirroring the greeting here of the greeting account of the smart contract. So we're defining the same class on this side. And then a schema, so just the greeting account again, declaring that it is a struct with a character of U32. Any information saying from the front end to the smart contract and vice versa. It will need to be serialized through Bosch, that is encoding this for third party. So that's what we do here. And then this part we're establishing the connection. So using the RPC URL, so either DevNet, here we're using the local RPC URL. Here we're using the local host URL, that is 8899. Connection established, all right. Then we establish the payer, so we're just getting the public key of the payer. So basically it's just checking that you have enough SOL to do the transactions. And then here, if you don't have enough SOL, it would airdrop you some SOL. Okay, check program. So in this part, it's a series of checks. So it's first to check to see if the program exists, if it has been deployed. So just getting the program from the program ID and checking its executable. And then we're creating a seed here from the public key and to the program ID, and with this random word that is hello. We're passing through the get account info again with this public key, and to say if to see if you have an account created for this program. So then it creates the account here and then sends the transaction. So this is this part of the process, creating account to say hello. You see here. So it didn't go through this part on the second time because we had an account already. So if here this is different than null, it would skip this part. So here the say hello is the actual transaction. So that's the important part. All the previous part were all setups. Some you could skip for your own project because this was all for this example. But here is the actual transaction. So this is just the console log, but then it creates the instruction here. So it has the public key, and then it has this variable here is writable to see if you could actually update the smart contract. So if this was false, you cannot increment the counter. Then it's passing the program ID and then the data. That is here a buffer that is empty, that has 0. Because in this case, we don't need to pass any data. We can just increment the numbers. There's no data from the front end to the smart contract. If we look at the smart contract on this side, we can find the same parameters here, the program ID, the data, and then the account that corresponds to the keys here. So it is the parameters we receive. So there's 3 parameters for the send and confirm, the connection, the transaction with the instructions, and then the payer as an array. All right, so this is the most important part. And then finally, we do a reporting. So that's just to visualize the number So we getting a count from the same public key. So that's the one with the seed. So any information that goes from the smart contract to the front end is serialized. So we need to use Bosch again to deserialize the information. The information is this data, account info data, that we got from this variable. And then we're passing the schema that we set up earlier, and then the greeting account, that is the struct. All right, and then finally we get the information in greeting. It's greeting.counter that gives us the number of the count here. Let's do one more time here to show you the whole process. So it's going through the main. So in main, it does the connection, it finds the payer, it checks all the program exists, that you have money and everything. Then it does the actual transaction, say hello, and then it reports the greeting with this final sentence here. All right, there it is. We did our first smart contract using the HelloWorld repo from Solana. It works. It all works, and I hope you understand a little better about Rust and about the front-end setup with TypeScript. If you have any questions at all, feel free to leave them in the comment section below. I'll leave all the links to the documentation in the description. And before we go, I want to talk a little bit about my own project, that is Titan Dogs. There are two aspects of the project. It is a developer community. So if you're a holder of the token, you get access to all the scripts I made in the GitHub. So you can go to holder and then you get the invoice to the GitHub here. And it is also a play to earn game. So if you go to game, there's actually a prototype going on where you can test the game and give some feedback. So it's a 2D strategy game that is tile based and turn based. So yeah, that's it. You can move from one tile to the other, and then enemies spawn from spawn areas. There'll be a multiplayer, there'll be power-ups and equipments, so it'll be very exciting. I'm building the game in Godot, and I'm doing the documentation right now, so you can see the scope of the whole project. We have a Discord server. If you have some development issues going through the videos, you can also send some screenshots to the dev help section of our Discord, where I try to assist, and some other members as well try to assist. You can also, if you're a holder of the NFT, go to the holder vote, where you get to vote for the next subject of the video. So that's quite interesting. You see, this video was actually voted by the community here, smart contract. So obviously this is introduction to smart contract. There'll be much more to say. So I'll do some new lines with that. But next in line, for example, we have a lot. We have the Photoshop basics at 4 votes. The holder snapshot with MetaBoss that could be also helpful for the NFT update, the metadata update for a hidden setting collection. We have a Nuxt website. So you see, you have a lot of subjects. We need some more votes so you can get one of our NFTs and vote on the next video you'd like. Thank you very much for watching. Hope that was interesting to you, and see you in the next video. Have a good weekend, guys. Bye.